Let's take a look at number 11 from homework 2.2. All right, so we're going to start off by finding all those domains. So let's take a look at F. So F is a fraction, so we are going to have domain restrictions. Remember, you get domain restrictions when you have a fraction or a radical at this point. All right, so we can't have a 0 in the denominator. So you set the denominator x plus 5 equal to 0. Okay, and sometimes you don't have to do this if you can just see it. Like just looking at it, if I said, well, what value of x would make that 0? Well, -5 plus 5 is 0. So -5 is going to be the answer. But if not, you always set the denominator equal to 0 and solve. So you can see that we would have to take away 5 from both sides. So we get x equals -5. So either you do the math like I just did, or you just look at it and say -5 plus 5 would be 0. Okay, so x can't be -5. Remember, this is what it can't be. If x were this value, we would be dividing by 0, which you can't do in mathematics, right? You can't divide by 0. So -5 has to be removed, but every value going this way is fine, and every value going to the right is fine. So our domain would be from -infinity all the way up till -5, union -5 all the way to infinity. Now we're going to do the same thing, but for G. So for G, if you look at it, well, 2 minus 2 would be 0. So x can't be 2. And if you can't see it, then you set the denominator equal to 0 and you solve. So we would have to subtract 2 from both sides. So that 2 minus 2 is 0. And 0 minus 2 is -2. Now that -1 that's in front of the x, we're going to have to divide by that -1. So that way it ends up being x equals +2. Remember, this is, again, what it can't be. So +2 would have to be open circled, but everything this way would be fine, and everything that way would be fine. So what we're looking at for the domain of G would be from -infinity to 2, union from 2 to infinity. Let's go put these two in. One of them has -5 removed. And then the other one has 2 removed. So basically the same thing. But just change the -5 to a 2. Okay. Now this is kind of tricky. We're looking for the intersection of these two. Okay, so that's gonna take a little bit. So let's draw them on top, stacked on top of each other. So one of them goes from, let me put, let's see, -5 on here. And let me put 2 on here. Same thing for G. I'm gonna put -5 on here. I'm gonna put 2 on here. And then same thing for the intersection. Put -5 and 2. So F had -5 removed. G had -2 removed. So we're looking for the overlap. So we can see this region's been double shaded. So I am going to include that region. But -5 itself has not been double shaded. So I have to open that up. This region here has been double shaded. So I'm going to go ahead and shade that. But -2 has not been double shaded. It's not shaded on G. So I'm going to open it up. And then this region has been double shaded. So I'm going to go ahead and shade that. So our intersection is going to have 2 unions. It's going to be from -infinity to -5. It's going to be from -5 to 2. And it's going to be from 2 to infinity. So let's go put that in for our intersection. And remember, that's going to be the answer for F plus G, F minus G, and F times G. Those are all the same. I'm going to copy it, Control C. because I know I'm going to be using it for f plus g, f minus g, and f times g. All right. Okay, so now the next one wants to know f times itself, right? Now remember, if you're taking f and you're multiplying it by itself, the domain is just going to be the domain of f. So it's going to be negative infinity to negative 5, negative 5 to infinity. No new functions were introduced, so it should be the same as f. Okay, now divided by. So remember that divided by, it's pretty much the intersection also. So I'm going to start there. If it's f divided by g, we have our intersection, which was pretty intense. There, there, and there. This is the intersection. But we have to exclude any values that make the denominator 0. So we have to exclude any values that make g 0. So let's go back, take a look at what g was. So g is, we're going to set g equal to 0. Okay, so we're going to set 1 over 2 minus x equal to 0. All right, so if we multiply both sides by the denominator to get rid of the fractions, these will cancel, but we have to do it here too. 0 times anything is 0, so we get 1 equals 0, which is nonsense, right? So this is a contradiction, so there's no solution. So this will actually never be 0, which means we're not going to get any new exclusions, no values excluded from this. So it's going to be exactly this typed in. Now, before I continue on, I want you to look at this before we did all this math. If I have 1 over don't care equals 0, there's not going to be a solution to this. You should be able to spot that right away. The only way to get 0 out of a fraction is if the top is 0, like 0 divided by 5, that's 0, right? 0 divided by 6, that's 0. If there's a 1 in the top, there's just no way this thing's ever going to equal 0. You want to spot that early so you can save yourself a bunch of time and having to do math. So the reason why I'm pointing that out is check out the other way around. G divided by f, well, if I were to set f equal to 0, so here's f, I claim there's no way this is going to be 0. The only way to get 0 out of a fraction is if the top is 0. And the top is not 0, it's 9. So this can't be 0, which means no exclusions, no extra exclusions, right? All right, so it looks like for both f divided by g and g divided by f, it's going to just be the intersection of negative infinity to negative 5, negative 5 to 2, 2 to infinity. We didn't get any additional values that we needed to remove. So parentheses, negative infinity to negative 5. I wish it would let me copy it, but I believe that once it's already been done, yeah, you can't copy it. Now I'm going to copy it so I don't have to type that thing in again. Okay, Control C, check it. Put it in for g divided by f. So a fraction will never be 0 if the top is not 0. This fraction, when does it equal 0? Never, because there's not a 0 in the top. All right, now let's go ahead and go to finding these actual functions. So let me grab this. Oh, so let me just take a screenshot of it. Let's go to a new slide because it's getting crowded on here. All right. Okay, so we have to figure out what f plus g is, f minus g is, all those. So f plus g of x, remember the x goes with both. So we just have to take f of x and add it to g of x. So that's going to be 9 over x plus 5 plus 1 over 2 minus x. Now, the laziness in me is saying, let's go check this and see if this works, or if I need to go in there and get it as one fraction, you guys. Okay, so 9 divided by x plus 5. We'll find out right now. I'm going to put it in. And then 1 divided by 2 minus x. Oops, not z. There we go. Let's see if it takes it. Cool. Okay, so we don't have to go getting common denominators and turning it into one fraction. All right, so the next one is going to be f minus g of x. Again, the x goes with both, so it's f of x minus g of x. So it's going to be the same exact thing, but just a minus between them. So 9 divided by x plus 5 minus 1 divided by 2 minus x. All right, I believe the next one is times, right? So f times g of x means f of x times g of x, because the x goes with both. So we're going to take this one, and we're going to multiply it by this one. Now, I would assume that they would want you to actually multiply, like the 9 times the 1, right, would be 9. And then to just take these two and show that they need to multiply. I don't think you actually need to FOIL it out, but at least show that they're multiplying. Let's see if that works. It does. Okay, so they don't care if you FOIL right now. They're just thinking, hey, we want to make sure you've got the big picture. All right, so now we got to take f with f. So f of x has to be multiplied again by f of x. So 9 over x plus 5 has to be multiplied by 9 over x plus 5. So 9 times 9 is 81. And x plus 5 times x plus 5 is x plus 5 quantity squared. So we're going to put an exponent of 2 on it. Cool, it took it. Sometimes you never know, right, what my math lab is going to accept. All right, so now we're going to do f divided by g of x. So that's really just f of x stacked on top of g of x. So this is kind of tricky right here. I don't think it's going to allow you to leave that. So this means that the top fraction is being divided by the bottom fraction. And it's been a while, but remember, you never actually divide with fractions. You flip the second one. So I'm going to flip it, and you make it a multiplication problem. So this is really going to be 9 multiplying by 2 minus x over x plus 5 multiplying by 1. Well, multiplying by 1 doesn't do anything. So let me see if it leaves it, if it lets us leave it like that. First of all, let me check and see if it lets me leave it as this. Because the laziness in me is like, how much math do I need to do here? So let me see. If it lets you leave this, I will be shocked, but let's see. Okay, it didn't. Okay, so it does want us to keep going, right? It does want us to do this flip and multiply thing. Okay, so now my next question is, well, how far does it want me to take that? Can I leave it as 9 parentheses 2 minus x, and then the denominator has to be, whoa, what do we say, x plus 5? So in other words, do I have to distribute that 9, or will it let me do that? It let me do that. Okay. I'm glad. It should make us clean this up. Nobody wants to look at a fraction inside of a fraction, right? This is way better on the eyes. So I'm very glad that it's programmed to make you go a little bit further. All right, so now it's going to be g over f. Well, we said just flip it. So I'm just going to flip the last answer we got. So x plus 5 is on top of 9 parentheses 2 minus x. Done. So let's go put that in. Don't think too hard on that one, right? You're just going to be flipping the previous answer. Watch, I get it wrong now. Okay, cool. All right, you guys. So hopefully that helps you with the last one of these really tough ones where we have all these parts to it and we have all these domain questions. All right, so that is number 11. All right, thanks for joining me, guys. Have a good day.